Welcome. I think everyone can hear me. I think we'll go ahead and get started and let people start rolling in. First and foremost, thank you for coming to this session. I hope it's going to be at least a useful next 50 minutes for you. As you can see, the title of the talk, as you know, is JavaScript HTML5 Rich Clients with Java EE 7. My name is Reza Rahman. I'm an evangelist with the GlassFish Java EE team at Oracle. Up there is my email address as well as my Twitter handle. Just so you know, the one thing that I did want to show you is that you can get the slide deck as well as the code examples for this session from these URLs. I'll show you the URLs for just a second. It's on SlideShare, okay, and it's under my account, which is Reza_Rahman, and the name of this slide deck is Java EE JavaScript. And also, the code examples are on my GitHub account, which is github.com m-reza-rahman, and the project name is Java EE JavaScript. Don't remember those. If you don't remember those right away, don't worry about it, because if you keep an eye on the Twitter stream for JFocus, I will tweet out with the Twitter hashtag both the slide deck as well as the code examples. So do feel free to check those out when you get a chance. Okay, so I think my motivation for the talk today is fairly obvious. Basically, what I want to tell you today is a bit about what the evolving JavaScript HTML5 rich client landscape. I think unless you're in some really exotic island somewhere, which please give me an invitation to get there, you probably have heard that this is a fundamental paradigm shift that's coming your way. And my goal today is to show you how it makes sense to align Java EE 7 with this landscape, and why, as a matter of fact, Java EE 7 is an ideal backend platform for such an architecture. And of course, finally, I will show you an actual demo code to do this. So I'll show you the value propositions that Java EE has in combination with JavaScript. If you were to get anything at all from my talk today, I think that is the most valuable thing that you can get out of it. I think it's a good starting point. It's a good bit of starter code that you can use for your own projects in similar types of architectures. Okay. So before we go too far, I think it's important to just take a step back and take a look at the industry and see what it is that is going on, right? So as you know, the thin client versus rich client debate is pretty old. If you've been in this industry for a bit of time, you know that it's always a question of, okay, where does UI logic really belong? Does it belong on the client edge device, or does it belong on the server? And we've gone through this pendulum back and forth many times over the history of computing. So we've started in the mainframes where terminals are really dumb, and hence really don't have any UI logic whatsoever, and really all of the logic, including the UI logic, is on the server side. Then we've gone on to another phase, sort of the opposite phase, which is client-server architecture, right? So you've had very heavy clients installed on desktops, where you would have UI logic and perhaps even some business logic, and perhaps not even a middleware server talking directly to the database. And that's your first generation of client-server architecture applications. And then you've moved on a little bit from there to moving business logic to the server side. And that is sort of like the J2EE, EJB era, right? That is really what what Java EE's roots are. It's a server side for very heavy clients on the installed right on the desktop as desktop clients. And as a matter of fact, a lot of my clients before I joined Oracle did exactly this sort of thing, right? They had a Swing AWT client or some other non-Java client talking to EJBs via EJB remoting. And now, of course, we then again in the 90s moved away from that model back to the server, right? So now we did UI rendering on the server and treated the browser as sort of a thin, dumb client. You don't do really very much. You just spit out some HTML at it, and that's really as far as it goes. And then you just do a form submit. You do all of your UI rendering, on the server side, and again, simply send some dumb HTML back to the client. And that HTML really is nothing much more than rendering logic, right? It's not really UI logic whatsoever. There is no if then else statement. There is no for loop there. It's simply markup that you send back to the client. And this has ruled for a while, right? So, you know, in 90s onward, even until today, that is the fundamental paradigm of doing server-side development, right? So things like JSF, Struts, Spring MVC have ruled for a long time, and they continue to rule today. Now, in the early 2000s, I would say, or late 2000s, 2003, 2004, 2005, you got this little bit of a shove to the client side, namely in this new thing called AJAX. Okay, so XML HTTP request, and the basic idea here is to make web pages a bit more dynamic, right? And to do some things asynchronously, so that the client doesn't have to incur the so-called request response cycle every time. In HTTP, and you have, and this is fairly pervasive today too. Most of you that are writing, you know, server-side applications today, even using something like JSF or Struts or Spring MVC, more than likely are doing a bit of the AJAX, whether you're doing it by hand or whether the tool suite that you're using comes with built-in support for AJAX. So, you know, I think most people are probably not doing AJAX by hand today unless you are using Struts or Spring MVC. If you're using something like JSF, you're probably using prime faces, or you're using GWT, or you're using Vaadin, which is nothing much more than sort of a more Java-friendly version of GWT. But that is really the tip of the iceberg. The XML HTTP request is the beginning. So because of the success of AJAX, you now have a set of interesting coincidences happening on the client side that make the client side actually a viable platform for doing the same thing that we were doing a few years ago, namely rich clients, heavy UI logic and heavy things like if loops and for loops, and perhaps even some business logic on the browser. And what is enabling this is a few things, right? So first and foremost is improving JavaScript engines, right? So if you are going to be doing if loops and for loops and UI logic on the browser better be able to at least perform acceptably, right? So otherwise, it's a no-go. And historically, JavaScript engines have been very bad at this, right? So they're horribly inefficient, and hence doing any kind of serious computing on the browser with JavaScript really isn't a very good very good idea. But this has changed with things like V8 and SpiderMonkey and the like, and even Oracle has taken this so seriously that we're now rewriting the Rhino JavaScript engine in the JDK, and including in JDK some rewritten JavaScript engine called Nashorn, whose primary goal really is, value proposition really is, it's much faster than Rhino. Okay, so a modernization of JavaScript engines that make it technically viable to do rich client development and to do serious computing on the client side. And also, hand in hand with that are two different other important and perhaps equally important phenomena. Better tooling, right? So very important. If you are going to actually do something like rich client development, something like true client server based development on the client, you should have good tools. And guess what? Prior to just a few years ago, the tools were extremely bad, right? I mean, good luck, writing any kind of non-trivial JavaScript that was going to work across browsers in a nice way, right? You'll be spending hours and hours just testing various versions of browsers and making sure your syntax works correctly. There's nothing wrong with your DOM manipulation and the like. So a big enabler in that regard on the browser is this little library called jQuery. Okay, it really makes JavaScript work, right? It adds some nice syntactic sugar, and it's especially good at manipulating DOM, which is one of the worst parts of JavaScript in terms of cross-browser compatibility. So on top of that, you also have different programming paradigms, right? That codify programming best practices, codify programming design patterns like MVC, right? And you have a whole plethora of them. And we'll talk about what some of those options are a little later on the slide deck. But again, a very important phenomenon, right? If you are going to do serious development on the client side, you better have a well-known pattern implemented like MVC. Otherwise, it's just going to be your your classic ASP or JSP code. It's not going to be maintainable over the long run. And the browsers themselves now come with much better tooling, development tooling. The development tooling support that we have today is unimaginable, 5 years ago. Starting from JavaScript debuggers to execution engines to essentially everything, almost everything that you would expect from a modern IDE is built right into the browser, so that you can actually do realistic development on client-side development on the browser. With that, I'm also going to introduce, again, another tool from Oracle named Project Avatar. Again, it goes to the JavaScript tooling story. Okay, so the third catalyst in this move or shift to the client side are standards themselves, right? So as you know, HTML, it's been quite a few years since the HTML standard was updated, and finally we do have we're beginning to see some real innovation in the standard space coming out of the W3C and IETF and the like to do innovation and better standardization on the server, on the browser side. Again, very, very important phenomena. Things like CSS3, things like HTML5, things like WebSocket, things like HTML components, which you probably haven't heard of yet. It's again another evolving idea in the standards bodies for browsers to make browsers much more reliable and much more capable platform for doing real development, as opposed to simply a mechanism for producing for rendering simple UIs. Okay. However, I do want to say that I'm not of the opinion that we should all just be blindly jumping into this world of client-side development and it's just wonderful and the only way of doing things. As a matter of fact, beyond the hype, which I'm sure a lot of other folks will sell you, the people that I'm actually talking to that are doing this sort of development model are telling me that this is really not a slam dunk. Okay, so you should really think about this and make sure that this is the right model for you. All right. So clearly, richer clients on the browser are right for some types of applications. There's no question about that. Right? So, for example, if you have highly dynamic interactive interfaces, very complex interfaces that require real-time updates, and you don't want to be navigating between a whole bunch of pages, this is a good model. You want a richer UI, and you want a browser-based UI to do this, right? If you have a very complex UIs, like good examples are the things that we've been implementing in Ajax, right? Mapping applications, or if you have software as a service applications, like putting something like MS Word or Excel on the browser. Yes, absolutely. There's a value proposition for doing heavy JavaScript development and heavy client-side development. Single-page applications, right? You notice that I've put in applets in parentheses and a smiley face. So really, what you're talking about here is when you say single-page applications, it's really the same thing as we were trying to do unsuccessfully back in the 90s with applets. This is the use cases where the HTML5 and rich client JavaScript clients are a good fit. However, these are not without their problems themselves. Okay, so for example, some of the problems that you may run into, with this sort of development model, is still the pains associated with JavaScript and HTML development. The HTML is a horribly weak standard, especially compared to something like Java or Java EE. Right? So even with jQuery, inevitably you will run into things like browser compatibility issues. You'll always have a question of, okay, how much can I rely on computing power and the browser versions, on the client and the like. On the server side, you have complete control. Right? That environment is yours. You know what is available and you know what you can produce. When you say I'm going to be dependent on the client, you're introducing a whole bunch of inherent risk in doing so, number one. And perhaps the biggest biggest drawback, biggest thing to be cautious about in this type of development model. And also, although JavaScript engines have increased in reliability, it's sort of questionable whether they're still up to par in terms of something like a static language like Java executed on the server side. There is going to be a question of can you actually do heavyweight processing, in JavaScript still, even with things like V8. Despite all the hype, it still doesn't quite approach the performance of server-side computing. And now you're contending, of course, beyond that question itself, you're contending with resources on the client side as well that you know nothing about. And also, in terms of the basic programming model, single-page applications themselves are not necessarily a very, very good fit for a large class of applications that most enterprise developers work with. Namely, applications that have workflows and multiple forms in various stages. Right? Trying to do that type of application in a single-page application, really what you're doing is you're taking 10 different applications and trying to put them in one window. Right, so it's not a terribly good model for that necessarily. Server-side development model again shines in that area. It gives you nice modularization, sort of nice separation of concerns, and all of the server-side development platforms are geared towards executing on this programming model quite well. And let's face it, the server-side programming model is quite strong. How many people here have used a server-side presentation framework, whether it's Struts or Spring MVC or JSF? Yeah, almost all of you, right? And how many of you would say that you're really ready to jump in and leave all of the stuff that you've done for the past 5 or perhaps 8 years behind, just like that? Again, very few, right? So it's a strong incumbent. There's definitely going to have to be a strong use case for this to actually take place. So my point I'm trying to make is I'm not here to hype you on rich clients. There's definitely a use case for it, and JavaE is a good mechanism, is a good backend for this sort of development model. As a matter of fact, I'd say that is really Java. At the end of the day, JavaE strong point. But don't be fooled. Okay, so be cautious and make decisions that are really right for you. In the long and short term, I suspect what is going to really happen is a coexistence. Okay, so some of you will continue to choose server-side frameworks. Some of you will go, very quickly to the client-side development model because it may make sense for your skill set or your team dynamics. And a lot of others, perhaps, will be living in a hybrid model, where certain parts of your application are using server-side frameworks, and then there's segments of your application, if you will, islands of your application that look more like these rich client-side UIs, much like what we had in the applets. Right? That again is generally speaking the applet model, and as well as the rich client model. What the rich client model has really played out to be for most cases, right? Even beyond HTML5 and JavaScript. Okay. All right. So let's take a look at, okay, so how does this architecture really look like, once you get into it? And the good news is it's actually very well understood, right? It's very well understood because we've seen it before. Okay, we've seen it before in terms of the client-server architectures that we've dealt with, 8 to 10 years ago, let's say in the late 80s and early 90s. So we know how this looks like. Generally speaking, the client will be responsible for client-ish things. Okay, so things like UI rendering, basic input validation, some logic, namely UI logic, UI-centric logic, not business logic, and mostly a lot of state. Okay, a lot of UI state will be stored on the client. Okay. On the other hand, the server, it's a nice segmentation of responsibilities, right? So UI logic. The server, on the other hand, is interested in more of the, I suppose, more of the servicey things. Okay, so UI-ish things, servicey things. If it looks like a service, it probably belongs on the server. right? So things like business logic, things like domain models, things like persistence, things like messaging, right? All of the things that that Java EE is really good at doing, all that stuff belongs on the server, right? So you have UI, you have services, and the glue is a web in this case. Okay, so the glue used to be things like RMI or Corba and the like, right? And those are generally internally conceivable applications. But now you've generalized that programming model, right? So the glue now is the web, and the glue is now HTTP, right? So now you can scale up this model onto the world as opposed to perhaps something internal to your application. The typical communication protocols of yesteryear, as I mentioned, used to be some things like Corba and EJB2, or COM, DCOM, if you're in the Microsoft world of things. The communication protocols in this new world are principally REST. Okay, and we won't go into the details of why REST is ideal for this, but take my word for it. REST for a majority of use cases, okay, because a majority of your use cases are still going to look much like RPC, stateless RPC. Just invoke this service, get some results, I'll maintain state, and I'll make another service invocation for you when I need to. For a small subset of cases, you will use WebSocket as a communication protocol instead. Okay, and this is cases where you need full duplex communication. You need a stateful protocol as opposed to a stateless RPC-based protocol, so a TCP-like protocol. And these are cases like real-time communication, chat, highly interactive applications, and the like, right? Where your application is really very chatty with the server. You know, there's a lot of dynamism going on, and also there's asynchronous state push down to the client that you need to you know, handle, react to dynamically on the client, right? So these are all cases for WebSocket. Now, surprisingly, most of the JavaScript tools that I'll talk to you about, excluding the browser, actually have very good support for REST, right? So all the JavaScript framework that I'll show you today has baked-in support for REST-based development. It's well understood and well documented APIs. Not WebSocket yet. Okay, so none of these JavaScript tools today, with one exception, will support WebSocket out of the box. You will need to do a bit of hacking to make that happen. As a matter of fact, I did a bit of hacking, you know, in my demo to make it work too. Okay, the typical data exchange format is going to be JSON, and guess what? It's well supported by Java EE, right, as I will show you. Okay, so let's take a look at why is Java EE then a good platform for this sort of service. Okay, now, in all honesty, let me tell you, this is really Java EE's sweet spot. Okay, I think we've always been in sort of an uncomfortable position in pretending to be a UI, pretending to be a player in the UI market, right? I think, you know, anything in Java EE, anything in server-side Java, you know, we're really much more comfortable with this paradigm, okay? So to act as a backend to the UI platform, that is where Java EE's roots, as a matter of fact, is. So naturally speaking, you know, we have strong points in this particular development model. So in this development model, the UI is this amorphous blob that we don't really care about much. You know, that's way out there, and it's written in JavaScript and HTML5. Okay, the way we communicate with it, as I mentioned, is REST. Okay, and it's well implemented in Java EE in terms of JAX-RS. Okay. And it's has some very nice. There were some very nice updates to it in terms of JAX-RS 2 and Java EE 7 for this. Similarly, WebSocket, right, and the communication protocol, the Edge API in there is going to be the Java API for WebSocket. Okay, again, first-class support built into the server right away. Much better support than you have on the client side, as a matter of fact. Okay, and then you have the helper APIs to help you with this protocol. So things like the Java API for JSON binding to do JSON processing for you, which we will see in just a second. Things like JAX-B. If you choose XML as your communication format, you have a nice declarative API to deal with that in Java EE, namely JAX-B. With all of these endpoints, you have a nice way of validating input, okay, making sure that your input is safe. Input is something that is good enough for your service. And the way you do that, again, a very, very nice declarative, powerful API in Bean Validation. And I'll show you how that plays in this model. You have servlets to support to act as a fundamental infrastructural block to do that. Okay, there's a number of things that happened in the servlet spec in Java 8.7 to power this sort of applications, namely first-class support for NIO. Okay, any Java 8.7 application server that supports WebSocket is required to have NIO to support NIO. HTTP upgrades, again, to fundamentally at the infrastructure level support the WebSocket model or any other model that looks like WebSocket that will come in the future that maybe some of you will develop. And then, of course, all of the things that that make it possible to write robust services in the backend. So things like EJB for transactions, asynchrony, scheduling, and the like. Things like CDI, very first-class, very powerful dependency injection framework. To glue together all of these pieces, including the backend and the interface pieces. And the backend, finally, the resource level APIs like JPA, like JMS, like JCA, like JTA. So again, a full set of full stack platform built right in with intelligent defaults, minimal configuration. All you really do is write your business logic. Okay, and I'll show you a bit of that today to see how it really looks like in practice. Okay. A little bit of a primer. How many people here know about JAX-RS? If everyone is familiar with JAX-RS, let's just skip this part. All right. So majority of you are. I'm going to skip this slide. Okay. You can take a brief look at it just to make sure you're not missing anything too big. It's just an example of how JAX-RS looks like fundamentally. Okay. Better question. How many people are familiar with the Java API for WebSocket? Yeah, that's what I thought. Okay, so let's talk about it for a second. As you know, as I kind of alluded to, WebSocket is a fundamental paradigm shift in how you do browser-based communication. Okay, browser-based communication is largely stateless and largely RPC-based. Okay, that's what HTTP is designed for, and it works really, really well because it's a stateful protocol. It scales extremely well on a global scale. Okay. The problem, though, is because it is completely stateless, there's a certain class of applications for which it is not a good fit. All right. So these are applications that require full duplex communication, require a stateful protocol. Okay. Some examples: chat applications. All right. Gaming applications. So let's think about gaming for a second. Let's suppose you have a massive online multiplayer game. Okay. You have a game state on the server. You have multiple clients attached to these, attached to this single server endpoint that is a state machine. Clients make requests out to the server. It changes the state machine, right? And the clients are making these changes potentially completely independent of each other in real time. The server changes its state in real time, and the server, as it changes its state, potentially notifies clients again in an asynchronous fashion. And perhaps all of the clients, what those state changes are on the server side, right? Imagine doing this in a stateless protocol. It's not possible, right? So you can fake it by doing things like long polling. So WebSockets are a solution to that problem, and it's an elegant solution to that problem. And it depends on a single neat trick, and that neat trick is the fact that although HTTP looks stateless to us, HTTP is actually built on a stateful protocol, namely TCP. Okay, TCP is a stateful protocol. You don't make a TCP connection and immediately upon a response from the other side close down the connection. That's not what you do, right? You keep you open the connection, you keep it open for a duration of time. Both the client and the server can communicate with each other. And multiple clients can communicate with one TCP edge point. And after a deterministic period of time, right, after you have some chatty back and forth, asynchronous back and forth between the client and the server, finally you close down that connection. Okay, so it's a stateful protocol. So What WebSocket in essence is, it's an escape hatch. Okay, so you establish the connection between the client and the server using HTTP, and then once you've established that client, you establish the connection, you have an underlying TCP connection that you can utilize. And the client and the server both agree to say, hey, well, let's not talk HTTP anymore. HTTP doesn't really work for us. We're going to bump down to the TCP level, and hence we're going to have a socket. All right? And of course, so it's a useful programming model, a useful protocol level paradigm for an edge case, right? And arguably, some people will argue this is a growing use case, perhaps. So the Java API for WebSocket is a server-side and client-side API for this. Majority of cases, you will be using the server-side API unless you're lucky enough to actually have a Java-based client. And don't be afraid; it doesn't look like socket programming. Okay, it looks very much like the JAX-RS programming model that most of you are used to. It's just POJOs, annotations, and some callbacks. As a matter of fact, it's a very small API. Okay, so those are the annotations that are listed there. That is pretty much 90% of the API of what you need to know about the Java API for WebSocket. And much like things like JAX-RS, much like things like servlets, it's highly pluggable and extensible. Okay, so you can build on top of this API. That is what it is designed to do, with the anticipation that there's going to be an ecosystem around WebSocket. Okay, simple example. I'll show you a more complex example in my demo. So this is basically a chat application. We're creating a set of peers. We have two callbacks, on open and on close. So basically, we get these callbacks whenever we get a new session, a new client connecting to the server, and when the client goes away, we get the on close. In this case, we're simply maintaining the list of clients. On message, when we get a chat message, we simply you have a POJO that you say, I want the payload and I want to know who this client is, and you annotate it with an on message, and that's all you need to do. The server does all the rest of the work for you. And in this case, I'm going through my list of session peers, getting their handle to their endpoint, which is get remote, and then sending down an object. Okay. So that's it for the server side. We'll take a look at the server side a bit more when we look at the demo. So let's think about the client side for a second a little bit too. So for the demo, I had an interesting conundrum, right? So what do I do in a 50-minute time span? Do I show you every single JavaScript framework out there? No, right? I've got to pick one. So this is what I did. Generally speaking, as a consultant, it's similar to what I would do. I did some basic research on the technological benefits of these, and got some opinions as to what people think as to the pros and cons of this thing. And as it turns out, it's a hard ecosystem to make sense of. Okay, there's no consensus which is a better way to do things, and which is not a good way to do things. And there's various different ideas of how you would go about doing this client-side thing. Excuse me. So what I decided to do is a bit dumber. I went on to Google Trends and put in the trends of all these things. The nice thing is Google Trends actually gave me some good answers. Okay, so if you look at the graph here, it's clear who the winners and losers are. Right, so looks like Backbone, had some initial success, and they're sort of going downhill. It looks like Ember and things like Knockout and a whole bunch of others are just sort of hanging in there, right? So they're not going down, they're not going up, they're just sort of in existence. But clearly, the market leader is Angular. Okay, so you can see the Angular, curve just going up and up and up. Okay, so I'm going to focus. My demo code is going to be Angular. Right. All right, Project Avatar is something that I wanted to talk about. I won't talk about it in great detail because I'm running a bit short of time, and I really want to focus on the demo. But I'll give you the 2-minute elevator pitch of it. It's an end-to-end JavaScript framework from Oracle. Okay, It's got both a server-side component and a client-side component. So you can write JavaScript on the server, okay? And it's basically the way you do that is because JDK8 includes Nashorn. And then there's also a client-side framework, much like the Angulars of the world. And if you so wish, you can use one or the other, or you can use them as one seamless stack. So you have JavaScript from end to end. It utilizes on the server side beyond Java some Java E capabilities under the hood, namely the ones I talked about, JAX-RS and WebSocket and things like JPA and the like. Right now it runs on GlassFish. More than likely it'll probably be supported in WebLogic at some point in time. It does have first-class support. It's the only JavaScript framework that I could find that does have first-class support for both REST, WebSocket, as well as server-sent events. Right? That's another variant, another type of protocol that you can use. It has support for integrated support for PhoneGap for those of you that are doing hybrid mobile development. Those are all good things about it. Okay, it looks very promising. I would definitely, I'm looking to talk to this to people who would receive it. In my opinion, I'm not a big proponent of JavaScript on the server side, but some people are. And this is a good solution for those type of folks. It's still very, very early. It's very, very nascent. As you can see, it's dependent on JDK8, which hasn't really been finalized yet. But it's in my mind, also means that it's a good time to get involved. Okay, it's a good time to evaluate it. It's a good time to get involved. It's a good time to give them feedback. The URL for it is avatar.java.net if you want to check it out. Okay, so enough talk, some action. Okay, and so I'm going to go ahead and start the demo now and go through some of the demo code. And the demo code is available here on GitHub. Okay, so before I do that, let me just take a brief moment and make sure to give you an opportunity to ask some questions. Because honestly speaking, I prefer an interactive session, right? I like people stopping me and asking me questions and me answering it. It makes this thing less boring, and you don't have to listen to me for 50 minutes on end. Okay, any questions? Questions, comments, concerns? Yes, sir. Microphone is going to be a bit tough. I can hear you. I'll repeat your question. Good. Okay, let me repeat the question. This is a very fundamentally important question, and it goes back to what I was saying before about none of this being a slam dunk. So, JavaScript clients, beyond being sort of a pain in the neck to develop, also have some inherent architectural issues. Things like security, accessibility. You mentioned one other. Security, accessibility, pardon? Integrity, okay, so I would count that as part of security as well, right? So, so these JavaScript frameworks are so new, they really haven't dealt with those issues very, very well, right? They're trying to deal with those issues, but it's a long way from getting there. So again, that's another concern that you should really be, you should think about carefully and evaluate very, very carefully before you jump in too deep. Okay. I don't know if this answers your question. All I'm saying is I agree with you, and it's a good point. No, it's the same. Yeah, it doesn't address those issues. Okay, any other questions? No? All right, let's move into the demo. Okay, so here's my demo app. I have it up and running. Okay, I'll give you a brief demo of it, and then I'll show you how the code looks like. I'll deal with the REST part first, and then I'll show you the. You know what? I'll demo the whole app for you, and then we'll just go through the application in one go. Okay, so let's do that. This is just because I'm producing a self-signed certificate from GlassFish, and the browser doesn't like it. It's a secured app. Okay, so I'm logging in as me, and here we go. Okay, basic to-do list. Buy milk. Right, take out trash. Date, night, change diapers, etc. Okay. All right. So I can go ahead and complete some of these things. I can change them. All right. I can go ahead and delete some things here. And as you can see, it's a rich UI, right? It's changing, on the fly in real time, without any server or client server communication that you can see of, right? And it's all nice and slick. All right, so let's do the chat interface. Remember, I'm logged in as me. I'll say hi. All right, I'll open up another browser window, and this is IE, and log in here. So I'll log in as probably my wife. Let me see. And you can see it's echoed back there. Okay, and you go back up here. Hi from Sweden. Right? It's a real-time application, as you can see. Again, it's all happening in real time. No client-server communication, and it's happening across browsers, across clients in real time. Okay. All right. So I am going to show you the backend first. Okay. So the backend code for the REST part looks like this, and I'll just breeze through the code without going through very much details of it. Okay, so the code, if you look at my code base, it is right here in to-do, and the primary interface here is a to-do resource. All right, so if you expand to-do resource, you will see that it is a JAX-RS endpoint. Okay, it's published out to to-do username. So once I log in, I'm logging into this URL with my username, to-do Reza, to-do Nicole, etc. It's application scoped. I'm injecting a service in here. I have several CRUD methods: post for create, put for edit, remove for delete, and get all for just a generic get. Okay. Looking at one of them, just take a look at, for example, the create operation. Okay, so for the create operation, I produce and consume JSON. All right, JAX-RS has built-in support for JSON. You don't have to do anything at all beyond simply marking application/JSON, and on this POJO, which hopefully I can open up for you. You simply have to say XML root element, and that's all you need to do. JAX-RS comes with a very nice utility called Moxie that will read all of this metadata and dynamically generate whatever you need to do for you. For the to-do create item, I'm getting a path parameter and a path parameter named username. Okay, and also I'm getting the object itself as a payload. I'm using bean validation right in the method parameters of the REST endpoint to say that this better be not null, and the size has to be between 4 and 14. Okay, so again, you're ensuring the integrity of your input data. The add validator annotation means that JAX-RS is going to take a look at the to-do item bean and recursively look for any bean validation constraints there. Okay, so I have several here, not null and size and the like. Once you've passed this test, like the input validation test, and you've gotten to your REST endpoint, you then enter the services. Okay, so navigate, go to implementation, and as you can see, this is a stateless session bean. Okay, so it's pooled, it's transactional, it's monitored by the application server, all of the things that you would want for a service. And it talks to a repository under the hood. The repository is implemented in JPA. I'll show you. Navigate, go to implementation, and it's just a JPA POJO, injects the entity manager and does the JPA operations. Okay, so that is it for the server side, right? Quite a bit of functionality without actually having to do much. On the client side, this is how things look like. So this is my to-do page. Okay, I'm using AngularJS here. It's an AngularJS application. You can tell by the ng-app attribute. Okay, I have my code broken into controllers, services, directives, and applications. Okay, so you have your MVC pattern applied there. The rest of the markup, you will see, it looks very much like a server-side app. Okay, so you have a label, a form submission to enter your item, new item, the text field that you saw. It has a callback to add item. Okay, and that's part of my controller logic. It has things like loops. So I'm looping through the list of items. Each one is a UL, right? So I have an ng repeat here, iterating through a list of items and the like. Okay, so you can take a look at this code. I won't go through very much detail of it. The part that I want to show you is how you can invoke, how easy it is to invoke the REST service. Okay, so that part is in JavaScript, to-do, and services. Okay, so this is very much like the proxy pattern. Okay, the remote proxy pattern that we all know about in Java EE, right? So it's, as I said, Angular has built-in support for REST. So when I create this service, I can say ng resource, which is the REST library for Angular. And then I simply, in that resource, I feed it the URL, right? HTTPS localhost port 8181, Java EE JavaScript main, the name of my application, resources, to do, the user ID and the item ID that I'm receiving as parameters from other bits of code. And then I'm passing in the user. The user ID is always set to principal, and you'll see that in my code, I'm actually pulling the principal out from JSP. Okay, so I log in, I'm authenticated on the user, and then I'm getting the principal name. The update does a put. Now, if you look at the controller logic again, okay, again on the add item. It's as simple as creating a new to-do item with implicit, JSON bindings in JavaScript, and simply say save, and that's it, right? And the item is pushed out to you, and then I'm doing some binding with the UI, right? Again, similar type of stuff with the rest of it. So very, very seamless, sort of very, very painless support for things like REST. Okay, so I have a chat server similarly. Excuse me. Okay, and that is a WebSocket endpoint. Okay, it's a chat endpoint, publish/chat. I have an encoder and a decoder configured here with chat message. It's a singleton because I want a single endpoint for all of my resources. and then on open and on close, I'm keeping track of my peers. On message, again, it's very similar to the code you saw before. I'm validating it just like I was before, right? So I'm using bean validation to validate this chat message, and the chat message has some bean validation attributes to it, right? Not null, size, and the like. And then I'm simply spitting out the basic remote, and I'm doing some error handling over here when I run into any bean validation issues. But you can take a look at that as well. Now let me show you the client side. I'm really running short of time now. Again, we're going to look at the services. Okay, and guess what? You have to do a bit of work here than I was doing before. Okay, so basically what this really is, this particular service is a facade over the WebSocket object that is built into the browser, right? So I create a new WebSocket, give it a WSS. It's a secure socket to port 8181, JavaScript main /chat. Okay, and then I register some callbacks. So on send, I say register to this function, and then this function will, this send method on my service is going to take two parameters, the sender and the value. And I'm going to call WebSocket.send and send JSON out, and I'm going to create this JSON object dynamically. Similarly, I'm going to set a listener, okay, for this service as well. You can register with the service, and when you register with the service, basically when I get an on message back from the client, I will invoke the listener, right? And if you look at my controller, this is how my controller code looks like in this case. Okay, so I create I'm sorry, I inject a to-do service here, and then chat is my to-do service. I invoke the setListener method, and when I get an actual message back from the client, I update this bit of my model called the messages, and then I also have to invoke scope.apply, and that basically notifies AngularJS, hey, something changed, re-render the UI. Okay, and again, on send, it's simply sending the principal and the new message. So definitely take a look at the code. I think, again, it's a fair bit of code that will show you how you can get started in this sort of programming model. Okay, I'm out of time. So in the bit of overtime, let me just go through the last bit of deck that I have. Then I'll open up for some question for Q&A if there's some time. Okay. Again, this is just a summarization. I won't bother repeating it. You know, basically, it's cool stuff. Java EE supports it, and there you have the code to get started with it. You can try all of this out. The demo that I showed you is running on GlassFish 4.0. WebLogic will have similar support very soon as well. Some resources for you. You know, you can take a look at that if you want to learn anything more about Java EE or anything about in what I showed you today, as well as some blogs that you can take a look at to stay up to date with Java EE. Okay, so that's all I have. I will take some questions if there's any questions until I have to leave the stage. Any questions on any of this? We can go back to the code if we want to. That's impossible to predict. So if Avatar is to win, it's going to win because it's a better programming model. So I think the programming model for Avatar is still in flux, and it's something that we could look at. The one nice thing there is, because it's from Oracle, we can make sure that it works nicely with Java EE. Okay. All right. Any other questions? All right. Thank you very much. Have a good afternoon.